Hello everyone, I'm Paul and today we're solving problem 1018, binary prefix divisible by 5. This is easy and here we show you my thought process and efficient solution. We are given a binary array nums, so let's say that we are given this. And a binary array, it's just an array with ones and zeros only. Our job is to return an array of the same size with booleans, meaning true or false. For each index, let's say we start from here, we take a subarray from index 0 up to the current I pointer. So in this case, we have this subarray. And this is the base 2 representation of the current number. Right now we have a 0. The base 10 representation is also 0. Now, if we take the base 10 representation and it's divisible by 5, we need to add true to this array at this index. Else, we need to add false. So, how do we know if this is divisible by 5? Well, we can take the current number modulo 5, and given that this is 0, we know that this is divisible by 5. If this was not 0, this would not be divisible by 5. So, now we know that this is divisible by 5, so we can add true at this index. Now the I pointer is here, and this is the current subarray. Remember that we always go from index 0 to the I pointer. So this is the binary number, 0, 1, and the base 10 representation of this number is 2 to the power of 0, meaning 1. And now we are doing 1 modulo 5. And this is 1, which is different from 0, so this is not divisible by 5. So we add false at this index. Now the I pointer is here, so we take a subarray from 0 to I, meaning we take all of this. And this is the binary number. How do we get the base 10 representation? Well, remember that we read this from right to left, and position 0 corresponds to 2 to the power of 0. Then we have position 1, which corresponds to 2 to the power of 1. Then we have 2 to the power of 2, and so on. So if we want to go from here to the base 10 representation, we take 1 2 to the power of 0, meaning 1, plus 1 2 to the power of 1, meaning 2. And 2 plus 1 is 3. So now we're checking if 3 modulo 5 is 0, and this is 3. Given that this is different from 0, this is not divisible by 5, so here we add another false. And now the I pointer is out of bounds, so we return this final array. So how can we solve this? There are different solutions. For example, you could take the base 10 representation of this entire array, and for this remember that this is position 0, this corresponds to 2 to the power of 0, then we have 2 to the power of 1, then 2 to the power of 2. So we will iterate this from right to left, and we will add every element. 1 times 2 to the power of 0 is 1, plus 1 times 2 to the power of 1 is 2, plus 0 times anything, it's 0. And this is 3. And once we get this number, well, we can check if this is divisible by 5, and in this case it's not, so we add here in the last position a false. Now we can divide this by 2 and round down this value, and this is as if we were removing this last bit. And if we do 3 divided by 2, we get 1. So now we're checking if 1 is divisible by 5. It's not, so we put another false here. Now we need to remove this bit, and we can do this by doing this divided by 2, and we need to round down this, so the result here is 0. Now we are checking if 0 is divisible by 5, and 0 modulo 5 is 0, meaning this is divisible by 5. So at this point we add true here. And by doing this, we can get the result. Now, there's a different solution, which is the following. I think this is overall more intuitive. We can have a prefix which is initially 0, and here we are storing the accumulated number. So first the I pointer is here at index 0, we are iterating this from left to right. First we have a 0, and we start by left shifting this prefix one position. Okay, so we are moving this 1 to the left in the binary representation and add the current number. So this will stay at 0. And now we check if this modulo 5 is 0. In this case it is, meaning this is divisible by 5. So here we add true and continue. Now we are here. The base 2 representation of this prefix is 0. And the base 10 representation is also 0. Now, if we left shift this one space and add this bit, now we have 0, 1 in binary, which is 1 in base 10. Remember that this corresponds to 2 to the power of 0, which is 1. So now the prefix is 1, and 1 module 5 is 1, which is different from 0, so this is not divisible by 5, meaning we add false here. Now we are here, and this is the current prefix. We can left shift this again and add the current bit, so we would get this. And this in base 10 is 3. Remember, this is 2 to the power of 0, this is 2 to the power of 1, and 2 plus 1 is 3. So the new prefix is 3, and 3 module 5 is 3, which is different from 0, so 3 is not divisible by 5, meaning here we add false. So this is basically the entire approach. Every time we get a new number, we left shift the prefix and add the current bit. And we can add this with a plus or with bitwise OR operator. It's exactly the same. And we repeat the same process, and every time we check if the prefix is divisible by 5. If it is, we add true, else we add false. Finally, we return this array. So with this in mind, now let's go with the code. First, n is the length of nums. The result is initially an empty array, and the prefix is initially 0. Now for every number in nums, every time we left shift the prefix by 1 and we add x. Here we can use bitwise OR operator, or you can use a plus. It's exactly the same. And every time we add to the result, prefix module 5 is equal to 0. So if this is true, we add true, else we add false. Finally, return result. So this is the entire code. Now let's submit this. As you can see, this works and it's very efficient. Overall time and space complexity here is big O of n. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.